Hello, ladies and gentlemen. Let's talk about this problem called Toeplitz matrix. So it's a matrix where every diagonal from top left to bottom right has the same element. So here you can notice 1, 1, 1, 2, 2, 2, 3, 3. So they're saying if every diagonal element is the same, return true. So how do we solve the problem? So the first thing is that when I was solving this problem, I thought about it like, hey, I should check the entire diagonal. And kind of confused me of how would I implement this. Then I realized it's an easier way to solve this problem where you are checking diagonal, but you're not checking the entire diagonal. Instead, you're going one by one. So you'll be at 1 at the beginning, and you check the location. So you could check location j plus 1, and then you're at 2. Then you are gonna check the location j plus 1 if they're the same, and once you're at 3, you do the same thing, and you're at the second row, and you do the same thing, j plus 1. So it's your I starts at 0, which is your row starts at 0, all the way to the length of the matrix minus 1. So you don't consider the last one, because as you notice, we are checking the top one with the bottom one. But if you're on the bottom, there's no any more list here, so you'll be indexed out of range. Same when you get to 4, you can check it diagonally, so that means you don't need the last element in a column when you're traversing it. So that's why in the implementation here, we start our row from the 0 all the way to length of the matrix minus 1, which goes all the way to here. It doesn't consider the last one. And the second, the inner loop would be we are gonna go from 0, which is a column. J is a column for each column, so it's gonna go all the way to here. It's not gonna consider the last element in each list. So the condition is if matrix I and j. So if this position is not equal to matrix I plus 1 j plus 1, which gives you this position, then return false. So the way everything works is going to go check 1 1 2 2 3 3, and then it's going to go to 5 5 5, and so on. And that's pretty much, and that's it. So the different way of approaching and solving this problem is by if you notice that in order to visualize what I did was I put the so for diagonal 1 1 1, the positions for the first one is 0 0, second one 1 1, third one is 2 2. So there is a property we can notice that if since 2 is a column and here's 2 is a row, right? So there's one property we can notice, and then this solution is called so group by category. So we know that 2 coordinates, right? We have R1, C1, R2, C2. So for example, 1 on the top and 1 down here diagonally. If they belong to, when do they belong? If they belong to the same diagonal, it turns out that 2 coordinates are on the same diagonal if and only if R minus 1 C1 equals R2 equals C2. So for example, what it means is that if you notice here, 0 0 1 1, right? So it's at the top one and this one. But so if you use this formula, so R minus 1 minus R1 minus C, R minus 1 and C1. So this is R here 1 minus 1 is equal to 0, and 0 minus 0 equal to 0. So they give us the same value, right, when we are subtracting their row from the column. So even here for 2, for example, the first 2 is located 0 1, and then this one is located 2 1. So if we are subtracting so 2 minus 1 would give us 1, and then 1 minus 0 would give us 1 2. So they're equal to each other. And for the third one it will be 2 and 2, and so on. So how can we use this property? So in order to use this property, what we do is that so since it gives you the same value, we can actually store it in a dictionary, and then if there is a mismatch, so if there's so next time we see so let me get you a solution and we can talk about it by looking at my solution. So go to submissions and I go click on this one and go ahead and say edit code. So here you have a dictionary, right? And you're gonna go through each element in the matrix, and you're gonna go through each column in the matrix. So it's column minus row here. And so what's happening is that since you already know that if you just 1 minus 1, it's going to give you 0, and 0 minus 1. So each of them are going to give you the same value, right? This would give you the same value, this one. If they're all the same diagonally, that means that subtracting the column from the row should give you the same value for each one, no matter if you use this, or this one, right? Same for 2, like we saw the property 2 minus 0, 3 minus 1, they both give you the same exact value. So we could actually use that property. So when we are at 1, we can store the value 1 at the index position of the column minus the row, which is 0 minus 0. So at 0 position we're going to store 1, and then the next time we see 1, which is it should be in the diagonal position. We are going to check if that position, if 1 is in that position, because at here the 1 is located 1 and 1, right? So we can easily know where 1 is, the previous 1 is. So we can say 1 minus 1 again, and then it gives us 0, and we check it if that's in the dictionary. If this is the same values, then they are diagonal, there's no problem. But if they are not the same value, that means they are not diagonal. So that's why the first thing we have to do, if I say if j minus I not in mapper, if not in dictionary, then the first thing we do, we put it in the dictionary and we access the value. And then however, if that's not equal to the mapper j minus I, if the values are not equal, so let's say something else is like 5, for example, here, and then we since the mapper has 1 here, but this should give the same exact index for you, so that's why you can easily access this. And then 1 and 5 is not equal, that means it's false. But if they're equal, but it's good. So that's why you return true. So this is a second way of solving this problem. Maybe if you try to implement this, you will get the hang of it. Yeah, so let's go ahead and talk about the second problem which I solved today. Was island perimeter. So the island perimeter, you're given a map in the form of two-dimensional integer grid where 1 represents land and 0 represents water. So here you have this where 0 is the water. So the entire point of is that so it says it's there connected horizontally and vertically. Yeah, and then and then the entire grid is surrounded by water. And so you basically have to find a perimeter. What is a perimeter? It's basically the length of the perimeter, meaning. So it's I can go image. So it's basically distance around the shape. So for example here 5 inch, 3, you just add them up. Alright, so they basically want you to find the perimeter of island here. So you see 1 is the island, and there's only 1 island, and so here's a representation, and the perimeter here is as we saw in the picture, it's everything here, here, right? And they're saying that in the problem, they're saying that one cell is a square with side length 1. It makes sense, right? This is 1. So this is a visual representation of this matrix. So here is 1, 1, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the answer is 16. So if it's surrounded by water or it's out of bounds, here is a water, that means we are counting it. But if it's surrounded by another island, the same island, it doesn't count as a perimeter, right? So that's a property to remember. So my first approach was a little naive because so what I did was, I can go to my submissions. So my first approach here is that what I did was, the way I solved this problem at the beginning is okay, I'll say edit code and then go inside. So the way I solved it at the beginning is that I went through each element in this, and once I saw one, I called a function called DFS, but it's not doing any DFS functionality. I just named it. I was trying to implement DFS, but I didn't really implement it. But so what it does is basically I'm passing, once I see one, I'm passing the top, I'm checking its top, I'm checking its left right here, check right, check left, check top, check down. So I'm basically checking everything, and then in this DFS function, I first check if past row and column are valid. If they are valid, I'm gonna check if that position is 0. If this position is 0, I increment my perimeter, right? But if that position is 1, I don't do anything, because if it's a 1 here, so you're not gonna increase the perimeter. Yeah. So, and if it's out of bounds, so if you passed in the top, if you're checking the top here, it's still considered a perimeter, right? You have to increase 1. So that's why I have else statement, parameter plus equals 1. So this was a naive approach, but it worked. But the better solution to this problem is this one. So I'll go ahead and edit code, and so here, so what you do here, the basic an approach you should take is that you have to count number of ones first, and then the neighbors. So for example, we know that if it has a neighbor, then you won't increase the perimeter, right? Yes. So what we're gonna do, starting from here, we're gonna go through each element here, each island. If it's 1, so what we're gonna do, if it's 1, we're gonna check its right neighbor, and we're gonna check its down here, this neighbor, the downside. Why do we do that? So why we don't check the left and right, the top? So the reason we don't do that is we starting from here. We're checking its right, we're checking down here. But if it's 1 here and here, that would be 2, right? It counts as 2 perimeters. It doesn't count as 2 perimeters, so it doesn't count as any perimeters. So alright, let's think about it this way. If there's nothing around this 1, there's 4, right? Because each side is 4. But if there is something, then you don't count it. Make sense? So that means if you have a neighbor down here, if you have a neighbor on your right, that means you're not gonna get 4. Instead, you're gonna get 2 perimeter, right? So if all of the ones didn't have any neighbors around them, then that would be like number of ones times 4, right? Because each of the cell has 4 sides and they're not connected to any other ones. But when it's connected to other ones, then it's gonna lose. So this one is connected to here, right? Now you're not gonna count this part. So that's why we check its right and we check its the down here. And if it's 1, then we increment our neighbors. So at the end we say 4 times number of ones minus 2 times neighbors. So why do we have to do 2 times? The reason we do that is, as I said here at the beginning, we start from the beginning and we are not checking the top and the left, right? Because we're starting from here. But however, so if you start here, let's say imagine this is 1 and we check its right. The right is here there is a neighbor, and down here there is a neighbor. So why are we doing that? Now that means if you go to here, you're not gonna check its left, right? And you're just gonna check its right and the bottom. So that's why we say 2 times, because since this is not checking the left, if there were a 1 here, the 1 you don't count the right side, the bottom of the 1, but you're also not going to count the left side of this, right? And then also for this one, you're not going to count the top. And because once you come here, you're not going to check the top, right? Because you're only going to check the right and the bottom. So that's why it's important to say 2 times neighbors, because you're skipping the check where you have to check for the top and the left, because you're already coming from here. You can just say 2 times neighbors. So also make sure when you're checking its right neighbor and then the bottom neighbor, you have to make sure it's not out of bounds. So that's it for this for perimeter, and it's an easy level problem, so you should be able to solve it. It's a little tricky. So thank you for watching this video, and I'll see you later.